Let's compute the volume using the shell method. The shell method is a little bit more refined than the disk method. I think you will find this method more digestible. Well, the shell method can be seen in two different ways. We can talk about the shell method with respect to the horizontal axis of revolution, or the shell method with respect to a vertical axis of revolution. If it's a horizontal axis of revolution, that's in terms of y. The formula is given here, 2 pi times the integral going from e to d, or c to d, excuse me, p of y times h of y times dy. Now h of y is the height, or the length of the radius. The radius is that rectangular slice. And then p of h is said to be the distance from the center of the radius to the axis of revolution. And because of the center, we get halves, and you get a factor over 2, and so that's how we get this 2 times the pi times the integral. Likewise, if it's so-called vertical axis of revolution, then the volume is 2 pi times the integral from a to b, p of x, h of x, dx. And again, p is the distance from the axis of revolution to the center of the radius, and h is the height of the radius, or the rectangular slice. Here are some steps to finding the volume by the shell method. Graph the equations and determine p, h, d of x, and dy. Find the radius, or the height. Talking about the same thing. The radius for the shell method is parallel to the axis of revolution, just the complete opposite for the disk method. In the disk method, the radius was perpendicular to the axis of revolution. Here for the shell method, the radius is parallel to the axis of revolution. If you're using dx and you note which is it dx or dy, you will note the difference based on the thickness of your rectangle. If you're using dx, then px is equal to x, or if you're using dy, then py is equal to y. And this is only if the axis of revolution is the x-axis or the y-axis. Otherwise, if the axis, number 4, if the axis of revolution is a line other than the x-axis or the y-axis, then p of x is equal to the line of revolution minus x, if you're talking about dx, until you get p of x, or p of y if the axis of revolution is with respect to the the so-called x-axis. And so p of y would be equal to the line of revolution minus y. Use the volume formula that we just gave above for the shell method to compute the volume. And I think after that, you should be good to go. So next, we'll look at some problems from this section.